Okay, so we have calibrated our data. We've combined it now into a single color image, and we've started to do some post-processing on it. Now it's time to get into deconvolution. Before we do that, if you haven't already and you're following along with this, you may want to save your project at this point. Now, I don't keep these project files after I'm completely done and I've created a final image, but while I'm in the middle of processing, it's always good to save your project. That way, you may have to process these images over multiple days or even weeks sometimes, and always coming back to that project and having exactly where you left off is always very nice. So to do that, you click Save Project, find a place where you want to save it, give it a name, and then hit OK. Now, I've done that already, so I won't do it again. But again, that saves all your icons that you may have created along the way, any images that are currently open and in use. It saves all that information so that you can bring that back up. All right, so we're going to get into deconvolution. I mentioned deconvolution is typically a process that you apply not to color data, but rather luminance data. And I didn't capture any luminance data when I was out getting this field. So one thing that we can do is we can extract the luminance data from this color image. If you have the image selected, there's an icon here that says extract CIEL component, the luminance component, and you click that and it creates a black and white version of the brightness, the luminance of your image. So if I stretch that, now there's no color at all in this. This is strictly black and white. But it's where we're going to apply deconvolution, sharpening, and a lot of other details. Once we're completed that, we will then recombine this luminance and into the color image data and replace the luminance data that is currently there. So we'll show that. All right, so deconvolution. A lot of things you have to do ahead of time to even do the deconvolution process. The first thing that you have to do is you have to generate a point spread function. Now, this used to be a tedious process. Somebody has taken the time to help automate this, which is awesome because it's a real time saver. And I use that now going forward, and it seems to work just fine. So we're going to do that first. Once you have a point spread function, you then have to create a support. Let me just open up the tool. You have to create a local support mask, which will help protect some of these larger stars that we don't necessarily want to perform deconvolution on, or the center, the core of the galaxies. We want to protect those because it'll start to do funky things on those types of objects in your image, and we want to protect those. So that's local support of protection. And then, depending on the image, you may also want to generate just a mask to deconvolve only certain aspects of your image. We'll see whether or not I need to do that for this image. We'll try both, likely, depending on how it goes. But before we can even do a deconvolution, we have to do all those other things that I just mentioned. So let's start with generating the point spread function. Fortunately, there is a script here that somebody has created, and if you don't have it, you can go out and download it. It's called PSF image, and with that luminance image active, which it was, I loaded this script, and you click evaluate, and it takes a second, and it's going to scan the image looking for all the stars within the image. And then I click create, which will create a very, very tiny image here, which we'll zoom in a second. And then unless you want to look at this data, I just say OK to close out this process. And so it created this star, theoretical star, based on the image that it went through and analyzed, and is going to use this point spread function now to correct and some of the stars in the image. And the whole point, as I understand it, and maybe I'm not exactly correct, but what it's trying to do is reverse some of the effects of the atmosphere, the distortion on the stars. Stars are supposed to be pinpoint objects, and because of our atmosphere, they come across as fuzzy dots. And so this helps reduce or sharpen some of those. There's a ton of information on deconvolution, way more that is above my head, and I'm not even going to attempt to explain. But if there's a host of information on the web that you can check out and see. But ultimately, I use it for sharpening and getting really, really sharp stars. And if depending on the image, I may use it for sharpening detail in nebulosity, or rather nebulae, or galaxy information. Very, very powerful tool. All right, so we have our point spread function. I need to create now that local support mask, which is essentially the stars that we want to protect, or the core galaxies that we want to protect. All right, so for deconvolution, we have now generated our PSF file, so we can select that. We still need to create a local support mask to protect the really, really bright areas that we don't really want to deconvolve, because weird things can happen in those areas. So that's what we'll do next. And there's a host of different ways, methods, techniques to do this. Neither are wrong or right. I'm going to just try. I don't know if this is going to work, but I'm going to try to create a range mask. And I like range mask because it has a preview mode, so it can kind of see what things are going to look like beforehand. And actually, before I even open up that thing, you can see where the really bright things are. This star, this star, this star. Maybe these smaller ones here will be included too, because if they're really, really bright, maybe they need to be protected as well. It's just because funky things happen in the really bright areas that we want to protect those while we're doing deconvolution. So let me open up the preview mode here, and you can see right away that it is already picking up those stars that I pointed out, as well as some of the other slightly brighter stars. And so I'm going to move the lower limit a little bit just to see how it reacts. I don't think I need all those stars that it had identified at 0.3, and I think, in general, that kind of captures the bright stuff. The two galaxies that are in the middle is a little surprising that those aren't there yet. I don't know if if you bring that down, that doesn't do anything. So I'm going to leave this at around, 0.664, I guess, was generally where I was. And then you can play with fuzziness and smoothness to impact the shape of the star. You can see the more smooth you get, the larger it grows. I don't want it nearly that big. If you go to 0, it's just pinpoints. But I do want a little bit of shape and size to it, so I'm going to stick around maybe 5. And then fuzziness, in this case, it's subtle. It's doing some stuff. It's impacting how the edges fall off. I'm just going to add a very, very tiny amount of fuzziness, because we're gonna make that smoothing a little bit with the convolution tool. So all right, I'm happy with this. I think that's what I would like to start with. Oh, it was still generating. So close the preview, generate that range mask. And it doesn't look like much, but that's it. Let me stretch it. Now that's more similar to what we were just looking at. But it is still a linear image. If I didn't stretch it, there's really not a ton of information there. Even though it is there, it's subtle. I want to apply a permanent stretch to this image. And so to do that, we use histogram transformation. I'm happy with these settings here that we have in screen transfer, and so I'll permanently stretch those and turn off screen stretch now, and now it is permanently displayed like this. Notice that the background is all zeros. which is a little bit darker than I had anticipated. Usually there is some value of sky in the background here. I think I'm going to leave it as is until it causes an issue, but just make note of that that's not generally always a good thing to have zeros, because this is 0, and then as I go through the star, you can see that jumps up to nearly 1 and then tapers back down to 0. Alright, so that's that, but now even though this taper is there, I want it to even be a little bit more of a taper, meaning not such a hard edge. I want it to be a little softer so that those transitions are a little more subtle. And so I'm going to use deconvolution to soften this. Deconvolution is just basically a blurring tool, and you can choose the amount of blurring that it will do, and then also the shape. If you change the shape, notice this example out here, it fades over a distance more so than if I go up high. The core is very, very bright, and then the fall off is over just 1 pixel. It's very short and fast. So this is a very hard edge, whereas down here it's going to be very, very soft. You can see how it's spread over. And I want to have a happy medium, so I'm going to set it maybe, let's say 2, I guess. And again, a lot of this is trial and error. And then, where the standard deviation is you can see how it gets a little bit more fuzzy. The higher you go, I'm going to go, let's go with, let's try this. Let's see what it looks like. And you can go into preview mode. And that's pretty good. Those are really nice, soft, blending stars that go into the background. So I'm happy with that. I'm going to apply that to this. And when you soften it like that, you actually lose some of the intensity of the white now. Remember, this was almost going up to 1 before. Now it's reduced. It's gone. It only goes to about 0.7. And so I want to bring that back because this is a mask, and I want to make sure that those areas are white. So I will, again, use histogram transformation, reset the tool here, and just slide this midpoint up. And you'll see as I do that, the centers get a little bit more white. So we'll try that. Apply that. Make sure screen stretches off. All right, I'm happy with that. That's pretty nice gradual transition. You can see there, it gets fairly bright towards the center, which is what I really want to protect, is the center core, so nothing funky happens during deconvolution. And I'm going to call this local support. Okay. And all that was just to create this local support mask. So I'm going to select that now. Oop. Nope, I don't want to close that window. I just want to minimize it. And I will tuck him away. You have to keep those open if you're going to reference them. And I'm going to keep the local amount at 70, or 0.7 rather. That's a good starting point. I don't usually generally impact that. So now the only question is whether or not I need to protect any of the other parts of the image that I don't want to deconvolve. Sometimes that is the background. Deconvolution is a sharpening and sharpening essentially. And I don't want to sharpen all the parts of the background, the little imperfections. I don't want to make this because and the effect is going to be adding noise. And that's the opposite of what I want to do. I want to make nice sharp stars, and if I can, try to bring out some of the detail in these little galaxies here if that's possible. So I'm going to try it without first and see what it does to the background and have no mask applied to it. And we'll see how that goes. All right, let's apply this. Now you're going to want to do deconvolution on a preview because it is so computer intensive. You don't want to try to do it the entire image right away, because there's going to be a lot of trial and error to get the right setting. So I created a preview. Zoom in here. You can see a good selection of stars, galaxies, the background. I'm going to stick with 10 iterations for now. We can always increase that. And really, I'm going to turn off global bright by just setting that to 0 for now. And the two parameters that you really play with at this point most commonly is the number of iterations and the global dark setting. So I don't know what's going to happen. Let's just try it and see what we get. It might be really ugly. All right, so it's not terrible. Let's see what it did. If you don't have this icon at the top, it's the undo preview. So if you're working on a preview, you can use this button to toggle back and forth. And so here's the stars. It did sharpen them. It made them a little bit brighter, but it didn't exactly do what I was hoping. I was hoping that some of the stars would get a little sharp. And if you see there, it's slight, but there's a dark ring around some of the stars. So I'm going to play with the global dark. I'm going to pause the video and I'll see what setting is the best. Okay. While I've been playing around with the settings, as I was applying deconvolution to this preview, it was also adding noise or sharpening, if you will, the minor, the very tiny structures within the background, which is exactly what I do not want to do. I don't want to introduce noise to the background, because that's going to be the next step, is to try to smooth this background. I don't want to have to further add artifacts that I will have to correct later. So I need to protect this background, but I still at the same time want to sharpen and work on the stars. So I have to create a mask that will protect the background and make sure that it does not deconvolve that area, but at the same time work on the areas that I do want to deconvolve. So again, there's a bazillion different ways to create a mask that would do that. What I'm going to do is create a clone of the luminance frame here. So I'm just going to create a clone of that, and I'm going to use this as my starting point. Obviously, this represents every single star and galaxy in the image, which is what I want, but I can't just use it as is. I need to make the whiters white and the darkers dark, and make it more like a mask. And then apply that to our image before we do deconvolution. So I made a clone. What I'm going to do is use screen transfer function and histogram to stretch this and essentially raise the black point and the white points accordingly to get more of a mask looking like image. So let's start with, first off, this image is not stretched. Remember, we're still in a linear state. If I remove screen transfer function, that's what it looks like. And I'll just do the nuclear button, and that's a good starting point. What I'll do is let's first just apply that. Let's get it to that point. All right, reset the screen transfer function. And now it's just a matter of feel. I'm going to raise the black point here on this image until I get it. I don't want to kill all the stars or the galaxies. I want to have some of that data here, but I'm just trying to find, a balance between getting a black enough background sky, because that's ultimately what I want to protect, without killing too many of the stars. And so I'm going to leave it right around there. Let's apply that. And reset screen transfer function again. And now I'm going to use histogram transformation to make the whites whiter. So let me go into the preview mode and just slide the midpoint I don't want to go crazy. I don't want to go too much. Just a little bit to make it a little bit brighter. In fact, actually, hang on. I'm gonna wait on doing that. Let's blur this first a little bit, because right now, if you recall, I took a copy of our image, so it is line for line, essentially mirroring the stars and galaxies in the image, and I don't want a hard line mask. I want a nice smooth transition so that you can't really tell where I masked things and where I didn't. And one of the ways we can do that is to enlarge the structures. So if this star, for example, if I grow this star a little bit and then make that transition fuzzy, it'll make it more smooth of a mask, and it'll be hard to tell where my mask started and where it stopped. So I have a saved process that I got from someone on the web. I think maybe it was Adam Block, who created this process container that has a couple processes in it. Morphological transformation, which will enlarge or dilate rather the image. So anywhere there's data, it will grow it. And then it'll immediately after that, it'll use convolution to blur it. And these are just settings that I have saved. I use this all the time. This is a very common technique when I'm creating masks, is that just to make that transition between where the mask starts and stops, I blur, I enlarge and blur. So I don't even look in that process container, I just drop it onto it, and you'll see that it grows things. Everything got a little bit bigger and everything, but also got a little bit fuzzier. And it's okay to have this moldy look here, because we're just using it as a mask. It doesn't need to be crisp and perfect. One last thing that I want to do is if I just look at these numbers, okay, so the whites are pretty white. If I go into the centers here, we're already at 1. So I think I'm just going to try to use this as is and see how this turns out. So I'm going to apply this now as a mask. And if I hit Control K, that will show the mask. The areas that are white are the areas that I'm going to work on and deconvolve, and the areas that are not white, that are red, are going to be protected. And so that's a pretty good representation. I'm getting some of the little smaller stars, certainly getting the galaxy cores and so forth. And so those are the areas that I'm going to deconvolve. And although it looks, this is a nice transition of my mask, where it's not just such a hard line. You can see it's kind of fuzzy, so that's good. All right, so let's zoom out. I will hit Control K to hide the mask. It's still applied. Notice that this is brown, but it's just not visible to us. So I'm going to go back to my preview mode. And now that we have a mask in place, we can continue to try to find the right settings for deconvolution. Now, when I did this, when I had the video paused, I found out that a good combination of settings was around having a global dark of 0.003 and about 20 iterations. And the way I figured this out is it was literally trial and error, and that's why you do it on a preview, to find out how little of global dark can you have, so the lower the number here, to make the stars smaller without introducing black ringing around it. And I'll show you quick what that looks like. If I go too far, let's say if I drop this to like 0.1, 20 iterations, and I apply that, because I'm working on a preview, this goes pretty fast, 20 iterations, but once you'll see, you apply this to the whole image, it takes a while to actually calculate this. Alright, so I already got some funky things going on this star over here. It's almost making it look like now a galaxy, which is something I don't want to do. And that's how I knew 0.001 was too much. But let me just blink this so that you can see the difference. Watch, for example, this star here as I blink. So it did its job. It made it a nice tighter star. But you can see there's also a black ring around it, which is definitely something I don't want. And look at the artifacts on this one, for example. that is just too much. And so that's definitely not something we want to do. So what we can do is we've taken the global dark too far, or we've done too many iterations, one of the two. And so you can raise this back up. Let's raise this up to, say, 0.003, and leave the iterations. We'll just change one variable and try it again. And it's trial and error. You're just trying to find the best balance of iterations in global dark to get something that is, nice tight stars, but without introducing black rings. And so this one's looking a little bit better. Still a little bit of artifacts on this star. This one really gets sharp. So that's getting pretty close. There's maybe just ever so slightly some dark ringing around the edges of some of the stars here. And one of the things that we'll do here is once we get settings that we think are optimal, then we'll apply this to some of the other parts of the image, make sure that we're not introducing other artifacts that we don't want. Take, for example, look at this little galaxy here. Deconvolving that has now made it just ever so slightly a little bit sharper. So I'm pretty happy with this, actually. I don't know that I'm going to change it much more. Let's see if it did anything else to other aspects of the image. So in this space, it seemed to be all right. Let's create another preview and check out this galaxy, and we can add another preview here, and let's look at that area. So let's look at preview 2 and test this out, make sure that we're not messing anything up. And if you'll notice, when it does this, the background is staying constant, and that's because we have that masked off. That's the whole point. So again, it's making nice tight stars, not too much dark ringing in the background. And if you look at the detail in this galaxy, I undo, this is before and after, there's a little bit of definition popping out of there that we didn't otherwise see. And so that's the power of deconvolution, is trying to correct for that atmospheric distortion that we have to live with if you're imaging from the ground. And so I think that's pretty good. Not too bad. Let's check the other area of the image. So here's another preview that I created. And just blink. So again, not anything that we're destroying. And that galaxy's getting a little bit more definition. I'm going to try one more area. These bright stars are always problematic if you're not protecting them. They shouldn't be affected because we had that local support mask in place. And if it's doing its job, it should not be affecting that. But let's just make sure. So we will run this. Okay. So now that's a little more than what I'd like in that star. But if that's the only area, then maybe I can live with that. That's a little dark ringing on that one. I wonder if I back off to, say, 15 iterations, if that will help. And that didn't really make that much of a difference. So the number of iterations didn't change it. Let me turn that back to 20. And let's increase this to maybe 0.0035 compromise. See if that helps just a little bit. And notice in the process console, I'm not getting any errors over here, which is a good thing. If you're getting errors here, then you definitely have to adjust your global dark setting so that it doesn't give you any errors. You should not have any errors when you run this process. All right, I'm going to stick with that. That's not too bad. This star's a little wonky, but maybe we can go back and fix him later. All right, so I am going to apply this to the entire process, or excuse me, the entire image. And that takes a little bit of time, so I'm going to pause the video while I do that so that you don't have to sit through this already long video. All right, so the process completed. I looked at the process console here, and I did not see any errors, no purple writing or warnings there, so it successfully executed the deconvolution. And so we are finished with that. So that was a rather lengthy explanation or demonstration of how to use deconvolution to squeeze out and eke out a little bit sharper stars, a little bit more definition on the galaxies, while at the same time not adding noise to the background. So the next step, next video, we'll pick up there and go into trying to smooth the background and eliminating noise in the image in general.